with you, students, to revise the most important or one of the most important chapters of organic chemistry. Students, I'm going to revise the chapter of haloalkanes and haloarenes for you today. Now, this is a very important chapter, as you know. It carries more weightage in the board exams. Fine, students? So before we go into the details, before we go into the tips and important tricks to be understood or to be remembered for the exams, students, first of all, let me tell you what is Eduauraa. Now you know that Eduauraa is a digital e-learning platform. This digital platform, students, is offering quality education at very affordable prices all across India, students. Eduauraa offering affordable education in different courses. It offers courses from classes 6 to 12 for 9 different boards. Along with 6 to 12th, it is offering courses of IIT JEE, NEET. That means entrance exams for your medical engineering and IIT is done at Eduauraa. And along with that, Eduauraa is taking courses of spoken English, competitive exams like IAS, IPS, and NDA, CDA, banking services. So all this is there on the Eduauraa app for you students. For that, you need to download the Eduauraa app and subscribe the Eduauraa app and get a 14 days free trial. Yes, students, this Eduauraa app, what are the important features? It has ebooks, mind maps, subjective questions, that is long and short answer questions with complete solutions discussed by the teachers, all expert teachers. Then you have the past papers, multiple choice questions, which are also solved for you students. And then you also have the performance monitoring reports. And along with that, students, you have interactive video lectures, which are consisting of 2D and 3D animations. So what are you waiting for, students? Download the Eduauraa app. Like the Eduauraa channels on YouTube. Watch the live lectures over there for free. Yes, students? So to begin with today's chapter, students, let us go ahead. We see that we're going to study about haloalkanes and haloarenes. Now, as the name of the chapter says, halogen derivatives of alkanes and halogen derivatives of arenes. That means you remove an hydrogen atom of an alkane, you replace it with an halogen atom, fluorine, chlorine, bromine, or iodine, it becomes an haloalkane. Remove one hydrogen atom from a benzene ring and add an halogen atom, it becomes an aryl halide. But you will see that halogen derivatives of alkanes and halogen derivatives of arenes, you study in detail for this particular chapter. First of all, students, let us go into the broad classification of the halogen derivatives or halogenated hydrocarbons, as the name suggests. Halogen derivatives of hydrocarbons is broadly classified into, if you see the broad classification, it is classified as aliphatic and aromatic, students, right? Now, in aliphatic, you have the classification as monohalides, dihalides, trihalides, and tetrahalides. What is mono, di, tri, and tetrahalides? That means one hydrogen atom of an alkane is replaced by one halogen atom. Two replaced by two halogens becomes dihalides. Three hydrogens replaced by three halogen makes it trihalides, and more than three makes it tetrahalide or polyhalides. Right, students? Aromatic halogen derivatives of hydrocarbons are what? They are the derivatives in which the halogen atom is attached to a benzene ring or an aromatic benzene ring. But further we see that as you have to study in detail for your syllabus, that is the monohalides. Now these monohalides or monohalogen derivatives of alkenes are also called as further classified. You can see that the classification is done on the nature of carbon and halogen bond. That means the carbon to which the halogen is attached, the monohalides are classified as sp3 hybridized, sp2 hybridized, and sp hybridized. whenever an halogen is attached to the carbon which is sp3 hybridized. What is an sp3 hybridized carbon atom which is attached to a single bonded carbon atom? That is, carbon which is containing the sp3 hybridized atom to which the halogen is attached is further classified into three types: alkyl halides, Rx. Then you have is allylic halides, where you see the halogen is attached to the CH2 carbon, but this CH2 carbon is attached to a CH carbon which is attached to a double bond. Halogen is not directly attached to the carbon carrying the double bond. It is attached to the neighboring carbon, which is sp3 hybridized. That is allylic halide. And the third is the benzylic halide. In benzylic halide, the halogen is not directly attached to the benzene ring. It is attached to a carbon which is attached to the benzene ring. Here we see that it is attached to the CH2 carbon. Right, students? Therefore, this is the first classification of monohalides. Second classification is carbon carrying the halogen must be sp2 hybridized. In that you have two types. One is aryl halides, which is your aromatic halogen derivatives of hydrocarbons. In aryl halides, the halogen is directly attached to the benzene ring. That means remove a hydrogen atom from the benzene ring, attach a halogen atom, it becomes an aryl halide. It can be chlorobenzene, bromobenzene, iodobenzene, etc. Then you have in that is vinylic halide or vinyl halides. In vinyl halides, what happens is the halogen is attached to the CH carbon or is attached to a carbon which is bonded to a double bond. So the carbon carrying the double bond also carries the halogen atom, makes it vinyl halide. Further, we see that the sp hybridized carbon. In sp hybridized carbon, when the halogen is attached to the carbon which is attached to a triple bond, makes it an alkyl halide. So this is the classification of monohalide, students, depending upon the nature of the carbon and the halogen bond. Now, students, we see that the dihalides are further classified into geminal and vicinal dihalides. Dihalides are dihalogen derivatives of alkanes, in which two hydrogen atoms of an alkane are replaced with two halogen atoms. Geminal dihalides, we see that the two halogen atoms are attached to the same carbon. And in vicinal dihalides, the two halogen atoms are attached to the adjacent or neighboring carbon atoms. Fine. So this is the broad classification. As far as your board exams are concerned, students, you will be concentrating on the monohalides. In that, you will also be studying is only the alkyl halides and the aryl halides. That means you will be studying the alkyl halides in detail, the aryl halides in detail. They are methods of preparation, they are nomenclature, and their chemical properties along with the physical properties. Right, students? So with this classification of halogenated hydrocarbons, students, now let us move further. Okay, students. Now we know that whenever it comes to haloalkanes, what are haloalkanes? I just told you, the halogen derivatives of alkanes. Now these haloalkanes or alkyl halides are generally represented as Rx, where R is your alkyl group. Right, students? Now these monohalogen derivatives of alkanes or alkyl halides in the IUPAC nomenclature is generally given a name as an haloalkane. It can be chloromethane, chloroethane, bromobutane, etc. You know the rules for naming the haloalkanes in the IUPAC nomenclature. Not going into the details of that. You know that a structure will be given to you and its IUPAC name will be asked, or an IUPAC name or a common name will be given to you and its structure will be asked for you. Yes, that part is a simple part which you have practiced and you know it very well. Let us quickly go or revise through the methods of preparation. We will study the general methods of preparation of alkyl halides or haloalkanes. Important method of preparation is from alcohols. Starting from alcohols, you can prepare alkyl halides or haloalkanes. Here we see that the first method of preparation is action of alcohols on hydrogen halides. That is action of alcohols on HCl, HBr, and HI. What you're supposed to remember over here is, students, that along with the HX molecule, what is the catalyst that is used? Whenever an alcohol is treated with HCl in the presence of anhydrous zinc chloride, you'll get the formation of alkyl chloride plus water, RCl plus H2O. Then when it comes with HBr, it should be carried out in the presence of H2SO4. So remember that, students. To give you the alkyl bromide plus water. And then when it comes with HI, you must carry it out in the presence of Ki plus phosphoric acid, that is H3PO4. Otherwise, the reaction is reversible. Ri plus water. So you can prepare chlorides, bromides, and iodide starting with alcohol. Now here you have to remember that, students. Whenever an alcohol is treated with HCl to give alkyl chloride plus water in the presence of anhydrous zinc chloride, that is a test for alcohol, which you will be studying in the next chapter. That is the Lucas reagent test. Okay, that details will be given to you in the next chapter. This is the first method of preparation, starting from alcohols. You can use alcohols to prepare alkyl halides in the next method also. That is the action of phosphorus halides on alcohol. Phosphorus halides are of two types: phosphorus trihalide and phosphorus pentahalides. That is a PX3 molecule and a PX5 molecule. Here you can see that this table or this chart shows you the preparation. That is, alcohol is treated with PCl5 and PCl3. What you're supposed to remember in general, students, if it's a PX3 molecule or a PX5 molecule, two products are common. Only one product is different. What is that? Whenever an alcohol is treated with a PX3 molecule, you'll get an alkyl halide, RX. Along with that, you will get is H3PO3. Phosphorus acid is the byproduct. But if you carry out the reaction with a PCl5 molecule or a PX5 molecule, you will get alkyl halide, and along with that, you will get POX3, and you will also get what? The HX molecule. Okay, so these are the products that you're supposed to remember. The difference is what? With the PX3 molecule, you'll get phosphorus acid. But PX5 molecule, you'll get what? You will get is POX3 plus HX molecule as the byproduct, along with the alkyl halide. So here I have shown you the reaction of an alcohol with PCl5, PCl3, PBr3, and PI3 respectively. Whenever it is an X3 molecule, phosphorus acid is the byproduct. Right, students? So all these reactions you have to practice very well. Once you practice them thoroughly, students, you should remember or solve questions based on organic reactions. Because the more number of questions you solve on organic reaction, that makes you more perfect. Moving to the next method of preparation. Now, if you see that, again, you can convert an alcohol to an alkyl chloride. That is, when an alcohol ROH is reacted with SOCl2. What is SOCl2, students? Yes, it is called as thionyl chloride. Now, whenever thionyl chloride is made to react with alcohol, this is a name reaction. And the most important thing in organic chemistry is the name reaction. What they ask you in the exams is mostly the name reactions. So reaction of an alcohol with thionyl chloride to give you alkyl chloride plus SO2 plus HCl is your Darzin's reaction. This reaction is considered to be the best method of preparation of an alkyl chloride. You'll ask me, why, sir? Because, students, here we see that the byproduct, sulfur dioxide and HCl, both are in the gaseous state. No separation is required. So you'll get alkyl chloride as the major product. Byproducts are in the gaseous state. They will leave the reaction mixture. Yes? So Darzin's reaction must be carried out in the presence of pyridine. That, remember, MCQs they will ask you. In thionyl chloride reaction with alcohol, what is the catalyst that is used? Pyridine. Fine. Moving to the next method of preparation. Next, we see that alkyl halides can be prepared by halogenation of alkanes. It's 11th standard reaction. When you study alkanes, organic chemistry alkanes under hydrocarbons in 11th. Halogenation means addition of an halogen to an alkane. That means a hydrogen atom of an alkane is replaced by an halogen atom. Halogenation of alkanes, that is RH reacts with X2 in the presence of UV light at high temperature to give you an alkyl halide plus HX molecule. Under this, you have is chlorination, bromination, and iodination, right? You have studied that in chlorination is carried out in the presence of sunlight or UV light, and bromination is carried out in the presence of AlBr3. Yes, iodination is carried out in the presence of mercuric oxide. Yes, so you have to remember the reaction conditions for the preparation of alkyl chlorides, bromides, and iodides using the halogenation process. In that, you study chlorination. The chlorination mechanism is what? Yes, free radical mechanism. Great, students. Moving to the next method of preparation. Quickly revising, you can also see the revision will definitely help you to get good marks in your board exams. Moving to the halide exchange method. Again, you see that, students, it is a name reaction. And what is the name reaction here in front of you? Finkelstein's reaction. What is Finkelstein's reaction? We see that halide exchange. One halogen is exchanged with another halogen atom. When I treat an alkyl chloride with sodium iodide in the presence of dry acetone, chlorine will be replaced with iodine to get alkyl iodide plus NaCl. So this reaction to be remembered because it's a name reaction. In halide exchange method, you have another name reaction which is asked in the exam, is the Swartz reaction. This is the only reaction in which an alkyl fluoride can be prepared. There is no other reaction which results in the formation of an alkyl fluoride. Where you see that an alkyl chloride, that is ethyl chloride, is made to react with mercurous fluoride, or you can take silver fluoride here, AgF also, students, to give you what? Ethyl fluoride plus mercurous chloride. If I take AgF over here, what I'll get? I will get ethyl fluoride plus AgCl, right, students? So here, this is Swartz reaction, Finkelstein's reaction, Darzin's reactions are the three name reactions we have already seen thus far, which you're supposed to keep in your mind. Clear, students? Moving to the next method of preparation. In the next method of preparation, we will see that it is the action of hydrogen halides on ethers. That means ethers are what? Organic compounds represented as ROR. ROR is an ether. This ether, when treated with a hydrogen halide HX molecule, what happens is here you see that one alkyl group, one R group will take halogen and form RX. Because there are two R groups, you'll get twice RX. And then you will see that the two hydrogens will combine with oxygen to form what? To form water molecule. Right, students? So this is again a method of preparation, that is, we call action of hydrogen halides on ethers for the preparation of alkyl halides. RCl, RBr, or Ri can be prepared using this method. Great, students. Let's move further. This is another important reaction of class 11th. That is, you see that addition of hydrogen halides to alkenes in hydrocarbons of alkenes. When you study the properties of alkenes, this is one important property. Now, you know that alkenes are unsaturated hydrocarbons containing a double bond. These unsaturated hydrocarbons are classified into two types, symmetrical and unsymmetrical alkenes. What are symmetrical alkenes? Yes, alkenes in which the double bond divides the carbon atoms equally. That means the number of carbons on both the sides of the double bond is same. And unsymmetrical alkenes contain unequal number of carbon atoms on either side of the double bond. Now here we see that an alkene, if it's a symmetrical alkene, if it is treated with an HX molecule, symmetrical alkene, when it treated with an HX molecule, no rule of addition is followed. What happens is hydrogen will get added to one carbon carrying the double bond, and halogen will get added to the other carbon carrying the double bond. That means addition will take place, double bond will become single bond, you'll get the formation of alkyl halides. But students, if the alkene is unsymmetrical, then you follow Markovnikov's rule and anti-Markovnikov's rule of addition. When will you follow Markovnikov's rule and when will you follow anti-Markovnikov's rule? Markovnikov's rule is followed in the absence of peroxide, and anti-Markovnikov's rule is followed in the presence of peroxide. That means when you have an unsymmetrical alkene treated with an HX molecule, on the arrow if there is peroxide, you will follow anti-Markovnikov's rule. If there is no peroxide, you will follow Markovnikov's rule. What is Markovnikov's rule of addition? It says that what? When an unsymmetrical reagent such as an HX molecule is added to an unsymmetrical alkene, the negative part of the reagent, that is a halogen, must get added to the carbon carrying the least number of hydrogens. So here in this example, if you see that I've taken propene, I'm reacting with HBr. In the absence of peroxide, bromine is going to the CH carbon because it is following Markovnikov's rule. But if it is in the presence of a peroxide, bromine is getting added to the CH2 carbon and not the CH because it is following anti-Markovnikov's rule. Anti-Markovnikov's rule gives rise to what? Peroxide effect, which is also known as what, students? Kharash effect. Good, right? So addition of hydrogen halides to alkenes follows Markovnikov's or anti-Markovnikov's rule for unsymmetrical alkenes. Clear? Okay. Let's move further, students. Okay, students. So these were the general methods of preparation of alkyl halides or haloalkanes. Once we have understood the important methods of preparation from your examination point of view, let us move into the physical properties. Now, because the examination is multiple choice question, because it's an objective question paper, therefore you should also know the physical properties because they can ask you the physical properties in multiple choice questions also. What are the physical properties of alkyl halides? We know that alkyl halides being polar in nature. Because they are polar in nature, they are insoluble in water. And they cannot form hydrogen bond with water because they're insoluble in water and they are polar in nature. They have higher melting and boiling points. We see that if the alkyl group is same, the boiling point follows the order what? R group is same, but halogen is different. So Ri will be greater than Rbr, will be greater than Rcl, will be greater than Rf. Boiling point increases with increase in molar mass, but boiling point decreases with branching. That means the boiling point of tertiary will be less than, secondary will be less than, primary will be less than methyl. So here we see that decreasing order of boiling points among the isomeric alkyl halides, that is primary, secondary, tertiary. What is the order? Primary will be greater than, secondary will be greater than, tertiary will be greater than methyl alkyl halides. Right, students? So here we proceed with the physical properties. All the physical properties are in front of you, students. Go through the physical properties, read the textbook properly, and understand the physical properties. So can they ask you questions, you can come to the correct answer. Once we have understood briefly the physical properties, let us summarize, students, the chemical reactions of alkyl halides. Alkyl halides undergo main type of reaction is what? Nucleophilic substitution reaction. It undergoes elimination reaction. It undergoes addition reactions. Yes? Let us first understand the important reaction of alkyl halides, that is the nucleophilic substitution reaction. What is a nucleophilic substitution reaction? You know that a nucleophile is an electron-rich species. It will attack an electron-deficient center. Whenever a nucleophile is substituted, that means a weaker nucleophile is substituted by a stronger nucleophile, it undergoes nucleophilic substitution reaction. Remember this. You have to remember that the alkyl halide is treated with different reagents and the products obtained are different organic compounds. First is that when an alkyl halide Rx is treated with aqueous QH, students, very important. Aqueous QH brings about substitution, but alcoholic QH brings about elimination. Don't forget that, students. So aqueous KOH or aqueous NOH or moist silver oxide. Again, silver oxide should be moist. That means silver oxide in water will give silver hydroxide. So whenever an alkyl halide is treated with aqueous KOH, aqueous NOH, or moist silver oxide, what happens is the alkyl halide gets converted to an alcohol, ROH plus KX, NaX, or AgX respectively. So formation of alcohols from alkyl halides. Next is when an alkyl halide is treated with sodium alkoxide. Sodium alkoxide is NaOR. Formation of ether takes place. Yes, ROR is formed along with NaX. Next reaction is important, students. Alkyl halides can be treated with potassium cyanide alcoholic and AgCN. So when it is treated with KCN and AgCN, see, the products are different. With KCN, you'll get alkyl cyanides. But with AgCN, students, you get isocyanide. That means cyanide is a nucleophile, which is an ambident nucleophile. What do you mean by an ambident nucleophile? A nucleophile which can get attached from both the sides. Either it can get bonded from the carbon end or the nitrogen end. So when it's treated with KCN, you get cyanide. With AgCN, you get isocyanide as the product. Remember this, keep this in your mind. Similarly, when alkyl halide is treated with potassium nitrite, that is KNO2 and AgNO2. Again, NO2 over here is an ambident nucleophile. With KNO2, you'll get alkyl nitrite. And with AgNO2, you'll get nitroalkane. See the difference. Nitrite and nitroalkane respectively, because nitro is again an ambident nucleophile. Whenever an alkyl halide is treated with silver salt of carboxylic acid, RCOOAG, silver salt of carboxylic acid, an alkyl halide converts itself or gets converted to an ester with AgX. So formation of ester, formation of alcohol, formation of cyanide, isocyanide, ethers we have seen thus far. Then we see that reduction of alkyl halide. When alkyl halide is treated with lithium aluminium hydride, it reacts with nascent hydrogen to form alkanes. Alkyl halide gets converted to alkanes or reduction with lithium aluminium hydride. When alkyl halide is treated with ammonia, NH3, gets the formation of amines, that is primary amines, RNH2. Then when that primary amine reacts with more of alkyl halide, you can get secondary amine. The secondary amine reacts with more of alkyl halide, you get the formation of tertiary amines. Then it reacts with sodium thioalcohol to give you what? Thioalcohols, right? SH. When it reacts with NaSH, it gets RSH, which is the thioalcohol. And then you can see that formation of higher alkynes also takes place when alkyl halides are reacted with the particular alkyne. Yes, students? So therefore, students, these are all nucleophilic substitution reactions which are important from your examination point of view. If you remember this chart, if you remember this flow chart, students, believe me, you can easily write down any chemical reaction based on this. That is nucleophilic substitution reaction. Now, once we have studied the nucleophilic substitution reactions, let us understand the elimination reaction of alkyl halides. In the elimination reaction of alkyl halides, whenever an alkyl halide is treated with alcoholic KOH, students, not aqueous. Aqueous brings about substitution, alcoholic brings about elimination. When an alkyl halide is treated with alcoholic KOH, what happens is KOH removes the HX molecule. It removes hydrogen from one carbon and halogen from the neighboring carbon. HX is removed. When HX is removed, the alkyl halide gets converted to an alkene. K will take the halogen and form KX, and OH will take the hydrogen and form water molecule, right? But here in 11th standard, you study one rule of elimination. What is that, students? Yes, it is Sedzef's rule of elimination. When do you use Sedzef's rule of elimination? Sedgwick's rule of elimination is used when you have two or more choices of eliminating an hydrogen atom, right? Suppose you have two choices of eliminating an hydrogen atom. You will always eliminate an hydrogen atom from the carbon carrying the least hydrogens, according to Sedgwick's rule, right? So remember that Sedgwick's rule is applied when you have two or more choices of eliminating an hydrogen atom. If halogen goes from one carbon, hydrogen must be eliminated from the neighboring carbon. And you Sedgwick's rule when you have two or more choices. But in this, what happens is dehydrohalogenation takes place, removal of HX molecule takes place, alkyl halides are converted into alkenes. Clear? Very clear. Moving ahead. Now, another reaction of alkyl halides is FRIEDEL-Crafts reaction. You study FRIEDEL-Crafts reaction of two types, FRIEDEL-Crafts alkylation and FRIEDEL-Crafts acylation. In alkylation, what happens is you study the reaction with an alkyl halide. Here we see the example of benzene reacting with methyl chloride in the presence of anhydrous AlCl3, where the hydrogen atom from the benzene ring is replaced by the methyl group. That means hydrogen is removed, methyl group is attached to the benzene ring. And then what happens? That hydrogen which is removed from the benzene ring takes the chlorine and forms what? HCl. Correct? So you get the formation of alkyl benzene. This is your FRIEDEL-Crafts alkylation reaction. Correct? I told you that alkyl halides undergo addition reactions. They undergo addition reactions with metals. Now, the first metal with which alkyl halides react is your magnesium metal. Whenever an alkyl halide is treated with magnesium metal, you get the formation of a reagent that is called as a Grignard's reagent. Okay, what is a Grignard's reagent and how is it prepared? A Grignard's reagent is generally represented as alkyl magnesium halide, RMgX. Here we see that when methyl iodide is treated with magnesium metal in the presence of dry ether, you'll get methyl magnesium iodide. That means there is addition of magnesium between methyl and iodine. This addition reaction forms the Grignard's reagent. Okay, you can take any alkyl halide or an aryl halide. You can get aryl magnesium halide or alkyl magnesium halide, which is a Grignard's reagent. But this Grignard's reagent, on further hydrolysis with water, will convert the alkyl group to an alkane, and you get the complex MgOH. Yes, students. So this is the formation of the Grignard's reagent or reaction of alkyl halide with magnesium metal in the presence of dry ether. Another important reaction of 11th standard, students, is your WURTZ reaction of WURTZ synthesis. You have studied under WURTZ reaction of WURTZ synthesis that when an alkyl halide is treated with sodium metal in the presence of dry ether, what happens is an alkyl halide gets converted to a higher alkane. That means when you take two molecules of an alkyl halide, two molecules of the same alkyl halide react with two atoms of sodium. The two sodiums are taking the two halogens and forming twice NaX. The R is combining with R to give you R-R, which is nothing but your higher alkane. When I trade methyl bromide with sodium metal, I'm going to get ethane. That means I'm going to get an alkane with double the number of carbon atoms. And you know that is the best method of preparation of alkanes containing even number of carbon atoms. You have studied in 11th standard, students. When you take a mixture of alkyl halides, you'll get a mixture of alkanes. So this is your WURTZ reaction or WURTZ synthesis when you take two molecules of the same alkyl halide to give you higher alkanes. Fine. Now, another name reaction, WURTZ-Fittig reaction. What is the difference here, students? You have one molecule of an alkyl halide and one molecule of an aryl halide. Yes, you can see that one molecule of an alkyl halide, one molecule of aryl halide reacts with two atoms of sodium. It's called as WURTZ-Fittig. WURTZ because alkyl halide is there, Fittig because aryl halide is there. Again, two sodiums are taking two halogens and forming twice NaX. The R group gets attached to the benzene ring. You'll get alkyl benzene, right? This is your WURTZ-Fittig reaction. Remember the names. All name reactions are important. Then you have is only Fittig reaction. WURTZ reaction, WURTZ-Fittig reaction, and Fittig reaction. In Fittig reaction, now you can tell me what is the difference? Yes, two molecules of aryl halides, two molecules of the same aryl halides on reacting with sodium metal in the presence of dry ether. Two benzene rings will be bonded together and you'll get twice NX, right? Diphenyl, correct? So this is the reaction with sodium metal. And this is for your board exams. Fine. Moving further. Reduction of alkyl halides, we have already seen once. Alkyl halides were treated with lithium aluminium hydride. Here you can see that an alkyl halide is treated in the presence of zinc and hydrochloric acid. Or you can say it can be zinc copper couple and hydrochloric acid. Produces nascent hydrogen. If you take two atoms of nascent hydrogen, how many nascent hydrogen will you require? If you take two over here, what is going to happen is one hydrogen is going to combine with the R group and form alkanes. So reduction of alkyl halides to alkanes. Then what is going to happen is the ZnX2 is the byproduct. If you take one hydrogen, you're going to get alkane and Zn is going to combine with X. So for that, what you'll do is, because Zn is forming X2, valency of zinc is 2, ZnX2. So take two molecules of alkane, take two molecules of alkyl halide, students, sorry, and take two nascent hydrogens. Yes. Once we have studied about haloalkanes, moving quickly to understand what are haloarenes. Now, haloarenes are halogen derivatives of an aryl group. That is, hydrogen atom of a benzene ring is replaced by an halogen atom. So here we see that ARX, AR is aromatic halogen, or ARX are haloarenes. Moving quickly to the general methods of preparation, right, students? So here we see that rashing process is what? Rashing process you have studied in alcohols or phenols, right? Where we see that chlorobenzene gets converted to phenol. But how is chlorobenzene first of all formed? Whenever benzene is reacted with HCl in the presence of oxygen and the catalyst CuCl2 at this temperature, condition 500 Kelvin, you get the formation of chlorobenzene and water. So we say that it's the first step in the preparation of phenol where chlorobenzene is obtained from benzene. Yes. Now, these are all important name reactions, and this table or this chart is important for you to remember. Benzene diazonium salt. What is the benzene diazonium salt? When benzene is treated with nitrous acid. Yes. HNO2 and HCl. Benzene gets converted to benzene diazonium salt, N2Cl minus attached to the benzene ring. Here you can see there are name reactions: Sandmeyer's reaction, Gattermann's reaction, and Bals-Schemann's reaction. Only see on the arrow the difference that will give you the product. Okay, benzene diazonium chloride treated with CuCl and HCl. CuCl and HCl. What happens is you get chlorobenzene. That is Sandmeyer's reaction. But again, instead of CuCl, you take only Cu and HCl. Again, you'll get chlorobenzene. Product is the same, but the name of the reaction changes. That becomes Gattermann reaction. Similarly, when benzene diazonium chloride is treated with potassium iodide, you'll get iodobenzene. And what is Bals-Schemann reaction? Important again. When benzene diazonium chloride is treated with sodium NaBa4, yes, in that what happens is first you'll get benzene diazonium tetrafluoroborate. This on heating further will decompose to give you what? Fluorobenzene. Because fluorobenzene is obtained, like Swartz reaction, alkyl fluoride was prepared. In this, fluorobenzene or aryl fluoride is obtained. Therefore, it's an important name reaction, Bals-Schemann reaction. So these are the important reactions for the preparation of aryl halides. Okay. Then you have by direct halogenation of benzene. Like you've done halogenation of alkanes, you do halogenation of benzene, chlorination, bromination, and iodination. Only remember the catalyst that is used. When benzene is treated with Cl2 in the presence of FeCl3, you will get chlorobenzene, C6H5Cl. When benzene is treated with bromine in the presence of FeBr3, you get the formation of bromobenzene. And when benzene is treated with iodine in the presence of HiO3, that is iodic acid, you get iodobenzene. This is halogenation of benzene to prepare chlorobenzene, bromobenzene, and iodobenzene. Understand the physical properties. Yes, what are the physical properties of aryl halides? Aryl halides are colorless, stable liquids with a pleasant odor. They can be identified by the odor. Odor identifies an aromatic compound. That's what it's called as aromatic. These are insoluble in water, but readily soluble in organic solvents. Most of them are steam volatile because they're heavier than water. You see that their boiling points are higher than the corresponding alkyl halide. Aryl halide's boiling point is higher than that of the alkyl halides. The boiling point rises gradually from fluoro to iodo compounds. Moving quickly to the chemical properties of aryl halide, students. We know that nucleophilic substitution reactions and elimination reactions. Nucleophilic substitution reactions and electrophilic substitution reactions take place over here. In case of nucleophilic substitution reaction, if you see the example of chlorobenzene treated with sodium hydroxide at 623 Kelvin at 300 atmosphere in the presence of acidic medium forms phenol. This is the method of preparation of phenol. Yes, students? So this is a nucleophilic substitution where chlorine is substituted with OH minus. Therefore, stronger nucleophile substitutes a weaker nucleophile. Then we see that there's an additional point to be remembered that on the benzene ring, on chlorobenzene ring, if there's a presence of nitro group, what happens is, if the presence of an electron withdrawing nitro group is there, we see that the substitution will mostly occur at ortho or para position. So if you have nitrochlorobenzene, dinitrochlorobenzene, and trinitrochlorobenzene, all are reacting under the same conditions. So you get the substitution. All the substitution can you see of the nitro group? The nitro group is at its position, but the OH is attached to the para positions, right? Or the position is para according, or it increases the reactivity of the halogens, presence of a nitro group. I told you that the second type is electrophilic substitution reaction. Under electrophilic substitution reaction, again you have is the halogenation. When a chlorobenzene is treated with chlorine, now remember that under this electrophilic substitution, we'll be studying halogenation, that is chlorination, bromination, and iodination. Then you'll be studying is nitration and sulfonation. Most of the organic compounds will undergo these type of electrophilic substitution reactions. In halogenation, if you see that chlorobenzene reacts with a chlorine molecule in the presence of anhydrous AlCl3, you get a mixture of product. You'll get a mixture of parachlorobenzene and orthochlorobenzene. In this, always remember the para product will be major and ortho product will be minor. Yes. Similarly, if you see that nitration, what happens is the chlorobenzene is treated with nitrating mixture. And what is nitrating mixture, students? Yes, it is mixture of concentrated nitric acid and concentrated sulfuric acid. But here you see that sulfuric acid is the catalyst, nitric acid is the reagent. So chlorobenzene will react. Again, you will get a mixture of two products, that is ortho-nitrochlorobenzene and para-nitrochlorobenzene. Keep in mind the major product is nitro, that is at the para position. Fine. Then you have sulfonation, is reaction with concentrated sulfuric acid. Chlorobenzene will again give a mixture of two products that you'll get is 2-chlorobenzyl sulfonic acid, that is orthosulfonic acid, chlorosulfonic acid, and para-chlorosulfonic acid. That is major product will be para, minor will be ortho. Right, students? Again, here you have is the FRIEDEL-Crafts reaction where you have FRIEDEL-Crafts alkylation process. Again, you will get ortho and para product with CH3Cl. Fine, students. So here we see that the product keeps on changing as we move further. Now, Nucleophilic substitution reactions, what you study is quickly, let us just revise, is SN1 and SN2 reactions, students, right? Now, from the examination point of view, remember the points of differences for SN1 and SN2. SN2 is substitution nucleophilic bimolecular, SN1 is unimolecular. We see that the kinetics, SN2 is second order, SN1 is first order reaction kinetics. Then we see that molecularity, it's bimolecular, therefore it is 2. It is unimolecular, therefore it is 1. We see that the number of steps SN2 reaction mechanism undergoes a one-step reaction mechanism, whereas SN1 undergoes two-step reaction mechanism. What happens in case of bond formation and bond breaking process? In case of SN2, it is simultaneous. Bond formation and bond breaking process takes place at the same time. Whereas in case of SN1, it's a two-step reaction mechanism. So first, the bond breaking process takes place, and then the attack of the nucleophile and bond formation takes place. In case of SN2, the transition state is only one transition state, intermediate state, whereas in case of SN1, it is a two transition state because it's a two-step reaction mechanism. Okay. The nucleophile in case of SN2 attacks only from the backside. That you know why. In case of SN1, you know that the theory part, what is optically active compounds, what is optical isomerism, right? This part you have to study in proper, you have to read it and learn it by heart so that the concept is clear. Under optical isomerism, you know is that what is monochromatic ray of light? First of all, optical isomerism, optically active compounds show optical isomerism. Optically active compounds which show optical isomerism, compounds having the same molecular formula, same structural formula, but what? Different orientation in space are optical isomers. That you know very well. For a compound to be optically active, it must be dissymmetrical. If a compound, organic compound, is symmetrical in nature, that means it can be exactly divided into equal halves, make it optically inactive. In that, monochromatic ray of light is what? A single wavelength of light. A single ray of light with a single wavelength of light is called as monochromatic ray of light. When a monochromatic ray of light is passed through Nichols prism, what happens? This monochromatic ray of light starts vibrating perpendicular to the direction of propagation. Yes? And that gives rise to what? Gives rise to a plane polarized light. And when a plane polarized light is passed through an organic compound solution, what happens is the plane of the plane polarized light gets rotated either in the clockwise or anti-clockwise direction. If it gets rotated in the clockwise direction, it forms dextrorotatory. If it gets rotated in the anti-clockwise direction, it forms levorotatory. Yes? Equal amounts of dextro and levorotatory compounds, equal amounts of dextro and levo forms of an organic compounds gives rise to a rhythmic mixture. The process of separating a rhythmic mixture, the process of separating dextro from the levo form is known as what? Resolution. What is chirality? What is a chiral carbon atom? An asymmetric carbon atom is a carbon atom which is attached to 4 different groups. If a carbon is asymmetric in nature, it will undergo optical activity, but that is not the fundamental condition. One of the conditions is that it must be an asymmetric carbon atom. That means a carbon attached to 4 different groups. We know that number of optical isomers is calculated with the formula 2 raised to n, where n is the number of asymmetric carbon atoms, right? Then you have is achirality. That means if there is a carbon is not attached to 4 different groups, that means an achiral carbon atom. Optical isomers, I just told you what is optical isomers. Then meso compounds. A compound which is containing chiral carbon atoms but can be divided exactly into 2 equal halves forms a meso compound. That is meso-tartaric acid is an example. Yes, students. So keep watching the lectures of Eduauraa, students. Keep watching the videos for detailed explanation. Our chemistry experts, we have multiple chemistry experts who have well explained the chapter of haloalkanes and haloarenes. So download the Eduauraa app, students. Watch the videos with 2D and 3D animations, and that will make the concept very clear. So what are you waiting for? Immediately like the Eduauraa channel, download the app, and watch and share it with your friends. So for today, your chemistry expert, Mohammad Farooque, is signing off. Have a nice day, students, and take care.